Good afternoon, my amazing scientists. I wanted to go ahead and read this text with you, which is motion of waves. Reflect. Have you ever thrown a rock into calm water? What did you see happen? Maybe you watched the ripples move outward from the center across the surface. You disturbed the water and caused a wave. We can see that ripple right over here, and we could see that in my science experiment. A wave is a regular pattern of motion. When a wave starts, the energy moves from the starting point in a pattern that keeps going until it runs into something, such as the seashore. There's enough energy in the wave to move objects. Maybe you have seen a boat bobbing up and down in the water. Even in a swimming pool, you can be moved by the force of the waves. You might have been floating in the calm waters of the shallow end when someone did a cannonball off the diving board. Suddenly, you are rocking back and forth as the energy from that wave hit you. Have you ever walked along a shoreline and seen items that had washed up on the sand? Maybe you collected shells, beach glass, and driftwood that you find carried by waves. They were brought ashore by the energy in waves. The very large surface waves you see in the ocean are caused by the wind that disturbs the water. The little waves that roll up and get your toes wet on the beach started miles away when the wind blew across the water. You can see those shells washed up over here. And then we could see the waves rolling in. Waves are everywhere. Waves are not only water waves, they can also be sound waves and light waves. A wave is a regular pattern of motion. We have that up here. A wave is a regular pattern of motion. All right, page 2. Reflect. How does the energy move through a wave? So here's the direction of the wave. And then we see our handy dandy little rubber ducky here. So as the wave is traveling, we see that this little rubber ducky is bobbing up and down. It is strange to think that the energy of the wave moves, but not the water. The wave moves through the water, leaving the water where it was before the wave came. The reason the water on the shore seems to move in and out is because the sandy shore pulls on the bottom of the wave and makes the top fall over or crest. If you recall my video on the beach, we talked about this on there. I also posed a question for you and said, what else could cause a wave besides wind on the surface? And it was something that would happen underwater. If you have an answer to that, go ahead and comment on Google Classroom. Send me a private comment. Try now. Make sure, if you would like to try this, that you ask your parent before you conduct any experiment at home. You can test wave activity for yourself. You will need a bathtub or a child's swimming pool filled with water, a toy that floats. Place the toy in calm water on one side of the tub or pool. Put your hand in the water and move it back and forth to create a wave. So we're just gently putting our hand in the water and moving it back and forth. We're not splashing and throwing water out of the bathtub or anything like that. Just some nice little gentle waves. Number 3, watch how your wave moves across the water. And 4, when your wave hits the toy, observe how the toy moves. So when you're making those observations, you want to look for, is the toy moving across the surface water, or does it just bob up and down in place? So what's happening there? If you conduct this experiment, please send me a comment or an email and let me know what you discovered in your experiment. Page 3. Look out! Other types of waves. Echolocation. Animals such as dolphins and bats use reflected sound waves to locate objects. They make a sound that moves in a wave out from their bodies. When the sound wave hits something such as a fish, the sound bounces back to the animal. The speed and the direction that the sound wave travels tells the animal where its next meal can be found. Dolphins use reflected sound waves to locate objects. Earthquakes. Earthquakes cause waves called seismic waves that travel through solid earth. The wave starts in one place, called the epicenter, and the seismic waves move out in all directions. Depending on the strength of the seismic waves, the energy of the earthquake can be felt from miles from the epicenter. And here's a picture over here of a crack. During an earthquake, the epicenter sends out waves that shake the ground back and forth. The sun and stars. The sun and other stars produce light that travels in waves through space. We see and feel the waves from the sun as light and heat. We learned about that in our energy unit. The waves from the sun take 8 minutes to travel to Earth. The reflected light from the moon travels for 1.3 seconds to get to Earth. The light from some stars travel for years or even centuries to reach Earth. So I have a question for you. Why would the light waves from the moon only take 1 minute or 1.3 seconds to get to Earth, yet the light waves from the sun take 8 minutes to travel to Earth? Why would that be? Please send me a private comment to answer this question. And then maybe we will talk about it in our Zoom discussion today. If you have any questions, please let me know.